In today's lesson we're going to look at geology geometry. So this basically deals with roads. So when we have a piece of land, we want to build a road through it, what have we to do to the land? So basically what you see on this slide here is basically what an answer will look like in the question. So what you have here is you've built a road and then you've filled in along the side here. So in this question we're looking to see how we're going to change the landscape when we build roads through it. But first of all, we're going to look at just a brief introduction, looking at different terminologies. Then we will look at profiles. So what a profile means when you cut down through the land. So we're using a vertical plane here, and what a vertical plane does to the landscape. So we'll be looking at profile. We look a small bit at map making, where these actual contour lines come from, and then we'll move on to roadworks and see how roads are change the landscape of the actual surrounding land. Then we'll look at a few sample questions. So what we have here is we have Achill Island, a map of it. So in this question we're going to be given maps and we'll have to do certain things with maps. But first of all, we better get familiar with looking at maps. Now, topography maps are the most common type. Right, now what they show is they show the shape and of the island, and then they show the relief. And what we mean by the relief is all these contour lines here. So if we look at this section here, we can see it's going from 100 meters all the way up to 600 meters. So we know if we flew over Achill Island here, we'd know that there'd be some hill on this section here, then there's another hill section here, and then this is a lot lower land along here in this section here. So this is what the contour lines represent. Now looking at the map here, what we have here is the roads. So all the roads then are highlighted. Next thing then is we've water, so we've all the rivers and lakes indicated here on the land. Then vegetation on these orange survey maps are shown in sections here. So we have a section here and a section here. So in Achill Island here they have highlighted 2 bog areas, so 2 peatland areas. Also what you might have is areas of forestry maybe marked out. Then the next thing that we look at here is the place names, so all the towns, any lakes with the names on them, and then road markings, what the roads are called. So this road here through Achill here is called the R319, so it's a regional road. And then the relief then valleys is we're looking at, we'll say the contour lines here. So here we have 3 main areas of change in height in the land. Next thing then is that we look at our bearings. So in this topic we'll be looking at different directions. So what we start off with is we start off with north and south, and then in this question here we might be asked on a map to travel north 45 degrees east. So what that means is you're traveling in a northerly direction, but it's an angle of 45 degrees from north traveling east. So this is what north 45 degrees east means. So you're traveling in a northerly direction, but you're going off at an angle of 45 degrees towards the east. So if we look at the next one here, we go north 45 degrees west. So again we're traveling in a northerly direction, so a northerly direction but 45 degrees west this time. So we're going in a totally different direction to the first one, but we're still traveling in a northerly direction. Now in this one here we have south 35 degrees west. So this here is important. We'll say the 35 degrees where it's measured from, because in these ones here 45 degrees is easy enough to set up here, but in this one here is where is the 35 degrees measured from. So what it is, it's measured from the south 35 degrees west. So it's always measured from the southerly direction out, and not a line from the center here drawn off at 35 degrees. It's measured with a protractor from south 35 degrees. Now what we also have here is another way of saying this is north 145 degrees west. So they're both the same direction. It's just using the principle north or south. So when you're given these, it'll either be north or south given first, and then the angle to whichever direction you're going to be heading in. Now, so what we have here is, if we take looking here, is locate two towns here. So we'll take this Clockmore down here and Dua here, and we want to locate what direction we're going. So we're going to be traveling from this point here up to this point here. So what we're looking at here is, this is your north and south, and what we're going to be doing is drawing an arrow here. So we're going to be traveling north 45 degrees west. So that's the answer in this question. Next, looking at this, we're going to look at just the topography of the land here and the relief detail here. So what we have up here is a section of cliffs here next to the ocean. So what we have here is, we're going to look at, we'll say, the relief, so how the land is formed. So basically we have the section of the land here shown, and basically the first line here is at 0. So 0 means sea level. And so when we're measuring for heights here, 0 is always sea level. Next thing then is the land is measured up in this case here 100 meter intervals. So what we have here is the first line here shows the sea level. So if we walk along here, we're walking along where the edge of the sea meets with the land. Now we're not taking into account, we'll say, whether it's high tide or low tide. What it is, it's an average between the two. So what we have here is the sea level here. Then we're going to measure up the 100 meter contour line. So the next line is up 100 meters. So we're going to draw in the next piece. So this here is up 100 meters. Next we'll then go 200, draw the next contour line, then 300, and so on, 400, 500, and top it off at 600. So what we have here is, this here is how the land is formed. Now if we look here, we take our horizontal slicing planes here, you can see where the contour lines are formed in. It's as if a horizontal slicing plane cuts through the land. Wherever it cuts through the land, that's where the contour line is formed. So what we have here is, these are each of the contour lines formed here. Now what we have here is Cairn Tool in County Kerry, and what we're looking at here is looking at profiles and how to draw a profile. So what we have on the map here is, we have a line going from A to B, and we want to draw the profile looking along this line. So when we want to do this, what we're looking at here is, we're looking at the land here, and we're looking at taking a vertical plane through the land so that we slice down through it. So we have the contour lines put in here in the graphic, and what we're going to do here is, we have our horizontal planes cutting across here, showing where the contour lines come from. So these are all our horizontal slicing planes. Now what we're going to do is introduce this vertical plane. So this here is a vertical plane here, and what you'll notice here, it's making a line now along the edge here where it cuts into the land. Now that line there, represented in black there, is what a profile is called. So that's our profile line on the drawing here. So if we remove the land, then this shows the profile here of the land. So it's a slice down through the land. Now in order to draw a profile, what we first of all is look at the scale. So in this case here, its scale is 1:10,000. So what that means is, for every 10 mils you're measuring up, you're going up 100 meters. Now so what we're going to do here is construct heights along here. So we're going to look in here 90 degrees to the profile. What we're going to do is start off with drawing our profile here. Now so what we're going to do is, first of all, look at the land here and identify a height in which we can start to map at. So what we're looking at here is, we're looking at 600, we're looking at 7, 8, 9, and then up to 1,000 here, and then what we're looking at is B there is probably 500. So what we're looking at here is, our first contour line here, measuring up 10 mils here, is 500 meters up. Next we're going to look at is another 10 mils up, we're going to go 600, and so on, and these are each of our height lines. Now what we're going to do is, all these points cross over these contour lines. So we know, say for instance this point here, it's crossing over to 700. So if we bring up this, we'll find it up here. So what we're going to do is look at each of these points. So starting here at A, first one here is crossing over this 700 line. So this here is brought up, marked off in this position here. Then next one 800, and so on with all the points here. So this here finds us our points. Then we'll plot it out then. So this is our profile now of this map. The next thing then is, if we want to look at the slope or gradient of what the land looks like. So if we're taking a section looking along the land to see how steep it is. So if we look at the section from B here, we'll notice here that it's a really steep climb on this section of the ground. Then if we look at another section, this section here is another really steep, and this is where contour lines are very close together. If contour lines are very close together, it's going to be a really steep gradient, so it's a really tough part to walk up on that piece of the land. So what we have here is 15 and 15. So what we've done is measured across 15 up 15, and it's given us an angle of 45 degrees, so it's a really steep angle here. And the same on this side here, it's 5 by 5, but it's a really steep section of land. Now if we take a look at another section, so this wider section here, so what we'll notice here is the gradient here isn't as big. So what it is, it's 30 over and it's only 10 in height here. So what we'll notice here is, if we have to walk up along this section here, it's a lot easier to walk up this section because it's not near as steep a slope. Now looking at these profile questions, so what we have here is a profile drawn here from 10 all the way up to 50. So these are the contour lines, and we want to draw a profile of the line AB. So basically what we have to start off with is all our height lines. So in this case here, we're going to start off with height lines 10 apart. So the first bottom point here is 0. Then the first height line is 10, 20, 30, 40, 50. Then we're going to bring up our points from A and all the way up and draw in our profile then. So this here is our profile of this simple map drawn in here, and this here is the highest point. Now normally when you're drawing this, we'll notice here that it goes from 50 to 50, but it's never going to be a flat line straight across. So what it is, you'll just round it off at the top here, and obviously it's going to be, if it's been moving up here, it's just continued up here and brought back down around. You wouldn't create a dip on this point and bring it back to the 50. It's going to be rounded off the top point here. So this here is measuring the highest point here of 53. Now that's estimating the height here. Now if we look at this one here, what we have is another profile drawn from A to B. So what we have in this question here is, we have a scale this time of 1:500. So basically what we're going to do is, looking at this, 1 mil on the map is equal to 500 millimeters in reality. So for every 10 mils we move up, we're going to be up 5 meters. So that's how we do it on the drawing. So this here is just to focus a small bit in on when we're setting up the height lines here. Now generally in Leaving Cert questions, it's basically, they're all either 10 mil or 5 mil intervals depending on the scale that's given to you. So we're going up 10 mil intervals here, and it's for every 10 mils we're going up 5 meter intervals. So what we have here is 20, 25, 30, 35, and looking at the map here, probably going up, maybe up as far as 40. We don't need to go up as 45 because 45 is over in this section here. So what we're going to do is bring up our points like before. So what we're looking at in this case is, this profile here now shows a valley. So this here is what is referred to as valley, is where the land from A to B, it slopes down from A and then rises back up. So there's a valley in this section here. Now what we're looking at here is, not all profiles will be taken horizontal. So this one here is taken at an angle of say 45 degrees. So what we have to do in this case here is produce an auxiliary. So an auxiliary, very similar to previous questions. Basically what we're doing is looking in right angles to AB, setting up a ground line. So in this case here, we're looking here, the lowest point is 40, so we're going to use 40 as our low point here. There's no real need to start from naught, because you're going to have a huge scale up along the side of the page if you start at naught, and the first 40 meters there's going to be nothing in it. So we're going to start at 40 here and then move our way up along here. What we're going to do here is, in this case here, the scale is 1 is to 2000, so what that means is every 5 mil intervals here it's going to be moving up 10 mils. So basically what we're doing is setting up our height lines here, so all the way up to 110, and then what we're going to do is bring up our points then from the plan view or from the map. So, and what you'll see here is this is the profile then given. So a really steep gradient here, so you can see how all the contour lines are very close together in this case here, and then it starts to widen out a small bit here, so that means the slope isn't as great. Now in this question here we have another profile going from A to B. So, and looking at this here, the lowest point here is 40. So what we have to do is set up our profile above the map here. So first profile, first height line there is 40 up, then 50, 60, 70, 80. So again, draw the profile here. Then in this question here, you're told that the bottom section here of the valley is the bottom of a lake, and then you're told that there's 15 meters of water, that the depth of the lake is 15 meters deep. So what you want to show on the map is how high up the lake comes on the surrounding landscape. So from the very bottom here, measure up 15 mils and then draw a line across here. So that shows, we'll say, the depth of the lake here. So what you can do is identify how much of the land is covered on that profile. So for example, this point here, if we brought it down here, this point here is where the edge of the lake is, and your feet are going to be dry in this section, they're going to be wet in this section here. Now in this question here, what we have is another profile from A to B, and then point X then is for an observation tower. So we look at how to draw in the observation tower after we've the profile drawn. So again, set up the profile, same as all the rest. What it is, the scale in this one is the more traditional scale, 1 is to 1000. So what it means here is for every 5 mils you measure up here, it's going to be going up 5 meters. So what we're going to have here is draw up all our height lines and then mark off all our points here. So this here is all the height lines marked off and our profile drawn. Now in this question then, we have location X, so we mark it on the profile, so it's marked on the profile in this location here. Next thing then is there's an observation tower drawn from here. So the observation tower drawn from here, what you're asked in this question is, will it be seen from B? So B is over here, will the observation tower be seen? Now the observation tower in this question here is going to be 26 meters. So that's the height of the observation tower that would be seen from B. So it has to be a minimum of 26 meters high so that it can be seen from B. If it's anything lower, say if it was only 23 meters, you won't see it. Okay, so if you're making an observation tower from here to see the surrounding landscape at B, it has to be a minimum of 26 meters high. Now in this question here, what we're looking at is another profile, and then what we're looking at is positions X and Z and Y, and what we have is in position Y and Z we have 2 windmills, and what you're going to be asked in the question is, from X will you see the 2 windmills given their height of 50 meters. But first of all we have to draw the profile. So quickly going through the profile again, these are all our lines put in. So that's our profile drawn. Next thing then is we'll bring up our points. So bring up point X and point Z. So Z is drawn up here. So this here is our wind turbine, which is 50 meters from point Z. Now in the question then is, will you see it from X? So first of all we bring X up here, and if we're looking through here, what you'll notice is this hill will block out we'll say this windmill. So for example, if you had a house built in X here, you would not see this wind turbine at all from your house. Now, next one here is if we look at Y, we do the same process from Y, draw from Y up 50 meters, and what you'll notice is this windmill, however, will be seen. So if we draw a sight line from X to touching the side of the hill here, we'll see the top tip of the actual windmill here. Now, in this question here, what we're looking at is where these profile lines come from and how we discover where profile lines are drawn on the actual land. So how do we get contour lines? So what we've done here is, this here is what an engineer has done. He has took satellite measurements from all these points here, and this is all the information he's got. So what it is, it's like throwing a net down over the land here, and these are all positions that he has got. So these are all the heights that he has got. So this point here is 94, then this point here is 106, and then this point here is 110. So, and what it is, we've measured across then 10 meters. So these are all done in 10 meter boxes. So this here is all done in 10 meter boxes. Now what we want to look at is finding a contour line. So what we're going to do first of all is find, we'll say, the 100 meter contour line. So to do this, we look at 94 to 106, and what we'll notice here is we want to divide that equally. So what we notice is there's 12 meters between them. So we're going to divide this line into 12 intervals. So this here is going back to first year TG. So basically what we're doing is a division of lines here, marking off 12 spaces, equal spaces long here, joining it back here and bringing in all our points here. So what we've located here is the 100 meter point here. Next then we'll do the same from the 97 to the 108. So again, this time it's 11 intervals. So what we do is draw off a line again at an angle, mark off 11 intervals, connect the first one back to the 108, and then draw the one from the 100 position. That gives us our 100 here. And then the next one, 95 to 100, that's 15. So 15 meter intervals. And then mark off the 100. And then the next one here, we'll notice that we already have the 100. So what this allows us to draw is, this is our contour line now drawn here. Now, and what we have is we've placed on the drawing here. Now if we do the same method now and say we look for the 100 meter or the 110 meter interval. So what we want to look at is for 110 meters now. So what we have is between 105 and 115 there's 10. So we divide this into 10, and then we find the position here for 110, and then so on, repeat the process here. So quickly going through this here is the 110 on this one, this here is 110 here, and then the next one here is, if we look here, where would the 110 be? It's between the 108 and 118. So again 10 meter intervals here. So what we do, divide this into 10 again. So this gives us 110 here, and then we have 110 already found here. So what we do here is we construct the contour line then along here. So that's basically where the contour lines are got and how they're created.
Hi, this is Paul Del Rio with Packy. You know, much more goes into building a road than just paving that surface that we drive on. There are long periods of planning and preparation that take place before even a single scoop of soil is moved. And when physical construction begins, there are things that go under the roadway that provide strength, structure, and drainage. Here's how it works.
Once the location of the roadway has been established, the first step is to evaluate the topography to determine the quality and strength of the existing material and how much soil will need to be removed or added. Before the construction process begins, the designer will consider potential impacts on the traffic system as well as the environment. This helps determine the best design for that particular location, such as the number of lanes and the path the road takes, as well as the thickness of the pavement itself. Once the engineers and the developer have chosen a design solution, the contractor can begin work. The site will need to be cleared of debris or vegetation. Depending on the topography, there will be a certain amount of both cut and fill on the project, or soil areas that need to be lowered or raised in elevation. The soil must be compacted in order to reach the proper strength to support the weight of the roadway and traffic. A grader machine is used to achieve the final grade or slope of the roadway subbase. Underlying electrical and water utilities and drainage are also constructed before the pavement is laid down. Stormwater pipes are installed along the length of the roadway according to the design. These pipes collect water from catch basins placed along the gutter. The storm pipes then feed into a larger system or possibly a detention pond. Roadways without a curb and gutter system may have ditches beside the shoulder, which also assist in transferring storm water. With the utilities installed and the soil at the proper grade, the contractor can begin on the roadway structure. This typically starts with a stone aggregate base. The base may vary in size and thickness depending upon traffic and drainage conditions. Asphalt is then paved onto the aggregate base by a paving train. The pavement can be applied in a number of layers and mixed types. Once the asphalt is compacted and cooled, it's time to paint the lane stripes and install reflectors, roadway signs, and possibly guardrails. After the contractor removes any equipment and cleans the site, the new roadway is opened for business. Proper maintenance of the asphalt pavement and drainage structures following construction ensures a safe and smooth roadway for years to come.
Many civil engineering projects include earthwork in them. In fact, almost everyone does. This particular project shows a roadway project. And as you can see in the background, this area used to be a hill. The original ground surface was somewhere near this red line shown, and the soil beneath that has all been removed or cut from this area. Therefore, we call this area a cut area of the roadway. In the foreground, the original ground surface was much lower than the current roadway, as shown by these yellow lines. The soil has been placed in this area to raise the ground surface. We call this a fill area of the roadway.
Here we have a roadway outside Headford and Galway, and what we have is this is the construction of a new section of road, and what we have in the video here is we have cut and we have filled. So we've embankments and cut. Along the right hand side here, land has been cut away, and then at the opposite side of the road here, land has been filled in. So there's a section of fill along here and a section of cut along here. So what we'll see here is as we move along the road here, the line here that's showing how far in the cut is going or how far the fill has to be brought out is showing, we'll say, what we need to find in any drawing questions. So what we see here is both sides of the road here have sections of the road that have been cut away, so obviously the land at either side of the road is higher. Then what we have here is another section here where we have an junction there. Now what we have here is sections of the road that have been fairly level with, so we haven't a lot of actual cut or fill. So as we move along the road here, then we sweep around this bend here, we'll notice the fence here is showing how far out the cut has been done. And then we'll say along the road here again, what we have is more sections here that have been filled in along here. So all this section here is filled in one side of the road, and what we'll notice on the other side of the road here is where the road has been cut. So what you'll notice here is the fence shows the boundary of how far much cut has to be done, and it eventually goes down to where there's very little. So basically what we have here is the road and the land is fairly level on that spot there. This is the next part of this topic. So what we're looking at here is earthworks. So this basically deals with roads, and after we have a road built, what do we do at the side of the road? So what we'll notice that in this drawing here is there has been a road constructed through the landscape here, and all the land around here is a lot lower. So what it is, if a car drives along the top of the road here, there's a great danger of it falling off the side here and crashing into the ground here. So what it is, obviously roads are never built like this. What we have to do is fill in this section of land along here. Now this is called embankments, sometimes called fill, so you're filling up against the side of the road, or you're creating an embankment along the side of the road here. So if we look at how this is done, first of all they have to determine what slope you want this embankment at. So what we have here is we've the embankment filled in here. So basically we have to first pick a slope on which we want this land to be formed at. So in this case here we might look at making a slope of 1 and 1, and what 1 and 1 means is it's for every 5 meters we go out, or every 10 meters we go out, we go down 10 meters. So that's going to give us an angle of 45 degrees. So all of this is placed in the 45 degrees. So what we have here is, this here is the triangle. Now this triangle is referred to side slope. So the side slope for the embankment here is 1 and 1. So in this case here we're looking at 10 mil intervals here. So what that means is for every 10 mils we go out, we go down 1 mil. So what that means here is we're going down 10 mils, out 10 mils. So that's now 50, and then so on for all the rest of them. So what we'll notice here on the drawing here is once we've gone down 10 mils and out 10 mils, what it gives us is a green line here that intersects with this contour line here. So that'll give us a point here. Then if we go down another 10 mils, it'll intersect at the 40 height line. So what you'll notice here on the map here, on the 3D graphic here, you'll notice that the 40 meters is marked off, and then again with the 30 and the 20 and the 10. So if we want to look at this and how we set it up on a drawing, then what we do is from the edge of the road, so we know the road is 60, we measure out 10, we construct a line, and this line is at 50. The height of this line is at 50 because we're going out 10 and down 10. So that gives us our point here. So this here is the 50, so it will give us a point here. Next one then is, if we do the same here, go out another 10, that'll give us a 40, so that'll give us a point here. And then the next thing is 30, and so on, 20, and then 10. And what you'll notice, 10 will give us 2 points, the 20 will also give us 2 points because we have the contour line here shown, 20 over here as well. And basically it's a matter of just joining these points together. Now starting off here, we have a point on the edge of the road, 60 here. So if the land is 60 and the road is 60, nothing happens on this point. There's going to be no fill at this point. So what it is, it starts from this point, and now it's a matter of joining up all these dots together. So this here is what the actual roadworks looks like for this question. And basically in this question what you're asked for is how much of the land has to be covered by either an embankment, or later on we'll be looking at how much of the land has to be cut away. So what we're looking at in this question here is we're looking at this land here being filled in here. So this here is how far out in the land we have to bring the fill to make it safe for people driving on this road. And obviously this is filled at the other side as well. Now the final thing we do here is we draw on tag poles on here. Now the reason we draw tag poles on it is this indicates the slope of this, so which way this is sloping. Tag poles always swim upstream, so what it is, this means that this land here is sloping up the way here. So this just illustrates the slope here. So tag poles always swim upstream, so what it means is this is sloping up the way, so up towards the road here. Now in this question here we have 2 sides of the road to be done this time. First of all, if we look here, the road level is 55. So if we look at the contour line here, 55, this here is our point here and our point here. So if we look at the map here, we'll notice that there's going to be nothing happening along the 55 contour line because the road is 55. But the rest of the section here has to be filled in, and this section here has to be filled in, and the same at the opposite side of the road. So what we have to look at is our ratio this time. Our side slope ratio is 1:1. So in this case here 1:1, and looking at the contour lines here, because it's 5 meter intervals, we're going to be measuring out at 5 meters. So we're going to measure out 5 meters, down 5 meters. So in this case here, 55, then we go down 5 meters, out 5 meters, we're going to have 50, and then we're going to have, this will give us our height line here, 50, this will tell us where it's cut, then 45, 40, and so on down along, and in this case down as far as maybe 25, or well 35 anyway. Okay, so what we'll do is here set up our lines here. So our first line is drawn out 50, so that gives us 2 points here, 50. Then we look at 45, then 40, 35, and we'll just get in 30 here. We might measure out 25, this point here is 25. And then it's a matter of marking off the point here, that's 55 on the edge of the road, and then the same here. So this here is how much fill has to be filled in against the side of the road and the side of the road here. Now obviously the same is done on the opposite side of the road, so basically what we do here is the same thing with the contour lines here. So 50, 45, 40, 35, 30 and 25, and then it's a matter of marking off each of these points on the road and then drawing in what our embankments look like, and then finally put in tag poles here. So you notice that they're going upstream here, so it's sloping up the way here, and this one here it's sloping up the way here towards the road, so it's sloping up towards the road in both of these diagrams here. Now in this question here, again looking at more embankments, but the difference in this question is it's a side slope this time of 1 and 2. So this does change, however. So what it means here, for every one we go down, we go out 2. So in this case here, if we're looking at 5 meter intervals between the contours, so 5 meters means if we're going down 5 meters, we're going out 10 in this case. So this here, how this changes the question when we're looking at side slope. So basically the easiest way to work out a side slope is you take this number here of 2 and you multiply it by the contour distance, difference between the contours. So 55 and 50 does 5 of a difference, so 5 multiplied by 2 tells you how far out on your drawing you have to measure. So you have to measure out 10 meter intervals in this drawing to get, say if the height of the road is 70 here. So what we have here, road height in this question is actually at 75, and then we have to mark off. So what we'll notice here is there's no contour line here shown at 75. So what we'll notice here is all this section here, so in the 3D graphic here you'll notice all the section here is covered with fill or embankments. So the first line here we measure out here will be at 70, so we're going to be measuring out 10 mils here. So this is out 10 mils. This will give us our 2 points of 70 here. Then the next line is out another 10 mils to get our 65, and then so on, 60, 55, 50, and this here is what our embankment looks like. And then to do the opposite side of the road, we're going out here 70 and we put in 65. And normally on the map here what you do here is you just extend on this line here, extend on this line here. You have to just guess where it's going to be going to, so obviously this will just be extended on. So and then in this question here just draw in the tag poles here, and obviously because we're dealing with all embankments in these first questions, it's sloping up towards the road here. Now in this question here what we have is more embankments here. Now in this question, this is a ratio that's common in Leaving Cert questions. It's a side slope of 1 in 1.5. So again, if we stick to the rule of multiplying the side slope here by the contour difference, so that's 5 multiplied by 1.5, that means for every 5 meters of a drop we're going to be going out 7.5. So that's how we work it out in this question. So if we look at the 3D or the 2D graphic here on the right hand side, for every 5 meters we go drop, we go out 7.5. So it's the 7.5 is the measurement we have to measure on our drawing. So basically how to do this is set up our lines. So out 7.5 to get our 75, Then the next one to get 70 is out another 7.5, out another 7.5, and so on for each of these. And then it finishes off at 55 in this question here. 80 is given to you here, and then obviously this here is the fill on this section of the road here. Now we don't actually quite know what's happening on either side of the road here. Is the land going up or down, or what's the story in this question? Now obviously the opposite side of the road is done the same way. So this here is what the fill on the opposite side of the road. So what you'll notice is, looking at this graphic here, the land at one side of the road is a lot lower than the land at the opposite side of the road. So the land at the opposite, at the top side of the road here, isn't near as low, so they didn't have to put in as much fill. In this section here, they had to put in far more fill because it came out way further out from the edge of the road. Now in this question here, this is the first of the questions looking at cutting. So not all land is going to be lower than the road. In this question here, the land is actually a lot higher. So what we have here is all this land is way higher than the road. So what we have to look at is how we deal with this when it's a lot higher. So basically it's very similar. We're given side slopes again, but the side slopes in this one here, and we'll start off with the same as for doing with embankments. We're going to look at 1-in-1 cutting. So what we're going to do is cut away the hill at an angle of 1-in-1. Now obviously if you build a road like this and you have steep walls at the side here, it's not safe because things can come off the sides here. So what it is, we have to cut this back in an angle to make it safe. So the angle in this question is 1-in-1. So what we have here is, this is the slice down through the hillside here, taking away this land here. So this is what we want to do in this question, is slice down through here. So we're putting in this slicing plane or an oblique plane at 45 degrees, and we're going to remove all this land here. So this is what we want to do in this question. So if we look at the 2D graphic here on the right hand side, we have the road level here at 30, and what we're going to do is looking at spacing out the contours. So in this question they're spaced out at 10. So what that means is, when we go out 10, we're going up 10. Now we're going up in this question because the heights have to be going up, because all the land is up higher than, we'll say, the road itself. So we're going up this question. So this is the main difference. In the previous question our numbers were going down the way. In cuts they're going up the way. So what we're doing is, to find the 40 height line, it's out 10, up 10. Then to find the 50, out another 10, up another 10, and so on. Now you'll see this drawn in the 3D graphic. So we have lines placed across here. So these are lines placed across here. So you'll see the 50 height or the 40 height line and the 50 height line, and where they intersect with their contour lines. 60, 70 as well. Now, so to do this on the drawing, we measure out 10 mils. And we're drawing this line, and this line is at 40. So the road here is at 30, but remember the land is going up the way, so these numbers have to go up the way. So we have the 40 point here, and a 40 point here, and another 40 point here. Next one then is 50, 60, and then finishes off with 70. 70 is the highest contour line. And what it is, it's a matter of drawing in our profile line here. Now we marked the 30 on the road here. So what's happening here is, the road is at 30, but the contour line is at 30, so nothing's going to happen on this point here. There's no cut required on this point. So what we draw in here is, we draw in our lines here. So this here is our lines put in. So this here is how much land has to be cut away. So all this land here has to be cut away. So all this land here has to be removed down to an angle of 45 degrees. So we draw in our tag poles here, and this case here, they're sloping away from the road because the land is sloping up away from the road, so they're going in the opposite direction in this question here. And now if we look at the 3D graphic, this now shows what has happened. So all this extra land here had to be removed. So all of this land is removed in this question. Now in this question here, we're introducing something new. What we have in this question here is, we have a road, and there's a slight turn in the road here. Now when we're dealing with turns in the road like this, especially with level roads, basically what we're looking at here is deal with this section of the road first and then deal with this section of the road. So what we have in this question here is all the land again in this question is higher. The road is 15 meters in height, and what we'll notice here is all the surrounding land then is higher than it. This point here is 15 contour line, so it starts from this point, and then after that all the land is higher, so it all has to be cut away. So what we're looking at here is a ratio 1:1 this time. The contour differences this time is 5 meters. So what it is, it's 1 multiplied by 5, so it's going to be out 5 mil intervals for our height lines. So to start that off on the drawing here, what you'll notice in the 3D graphic, we have our height lines measured out here. So we're starting off at 20, 25, 30 all the way up to 40. Now, so what we're going to do is our first line is out 5 mils, and that gives us our height for 20. Then we're going out 25 and so on for each of these lines here, out as far as the 30 point or 40 point. Now this here is the first profile. Now what we're going to look at then is draw this in. Now we're going to draw it in lightly first because we don't know where to finish it over here, so we have to look at how we finish it over here. We can't just continue on because this is not, the road has turned off at an angle here, so we're not going to be doing the rest of this with these height lines here. Next we'll do the opposite side of the road, so again quickly going down through it. This here is the same thing done here. Now we're only going this much past the edge of the road here, we're not doing any more. Now what we have to look at is deal with the next section of the road. So the next section of the road, as we did before, measure up 20, measure up 25, 30, 35, 40. So what we have now is we have the cut done for this section of the road, and what you'll notice is they'll intersect with the cut on the other section. Now if we do the same on this point of the lower section, what we have is 2 lines drawn in here. Now where they cross over is the key point, so where they're crossing over is where the cut finishes. So it's the same, so when we're drawing in the profile is drawn up as far as that intersection point, and then it's continued on the next section here. It's the same on the bottom of the road here. This here is our intersection point, so what it is here, our profile is drawn along here and then drawn from this point on here. So this here is our 2 sections of cut. Then we put in our tag poles into the diagram here. So that's our tag poles put into this question here. Now in this question here, very similar again, the height of the road this time is at 60 and we've got a bend in the road again. So basically very similar again, our side slope this time is 1 and 1.5, again quite common ratio to get in Leaving Cert questions. So what we're looking at here is the distance between the contour lines here is 5 meters, so it's going to be 5 multiplied by 1.5, which is going to give us height lines of intervals of 7.5. So this here is your 7.5s. Then from the edge of the road, the next one would be out 15 from the edge of the road, but we've measured them out in 7.5s. So what we're doing here is out 7.5s, so the road is 60, so it's the first height line is 65, 70, 75. So this here is our section here done. We'll do the lower section of the road also. So it's only up as far as 7.5 or 75, and this is this section of the road done here. Now what we'll do then is we have to deal with this section of the road. So this section of the road then, again we start off our height lines. So our first one is 65, 70, and what we have here is an intersection point here, and then we'll do the lower side of the road. So 65 is here, 70 is here, 75, and we have 80 in this question here. So basically what we have here is this road, and where they intersect here, that's the key point. So we join a line from the edge of the road here to this point here, draw in our contour and finish our contour here. We do the same on the bottom section, and that's our contour. And last thing we'll put in is our tag poles here swimming upstream, so going away from the road when we're dealing with cut. Now in this question here we have an actual bend in the road, so I'm going to skip on through this fairly quickly. So slope of 1 and 1, and what we'll notice is it's 5 meter intervals, so basically 5 meters, the road is at 45. So what we do is we do the 2 level sections here going out 5 meter intervals, marking off this section here, and then do the lower section of the road here again. Then if we want to do the curved piece here, now the curved piece, it's really no more difficult. All we're going to do here is set up a line using the center point for the curve, and then from the edge of the road is 45. So what we're going to do is measure out our 5 mil interval and swing an arc of 50 here. So this will cut into the 50 contour line. Then do the next one, 55, swing it until it cuts into the 55, and so on with 60. And that's how we deal with the curve on the road. So if we're dealing with a curve on the road, that's how we deal with it at the bottom. Now the inner curve here is done the very same thing again, remembering the measurements are going up the way. So even though we're getting closer to the center point, our measurements are going up the way. So we're coming in 5 mils here, but this here gives us our 50. Next one here is measuring 55, so again stepping in 5 mils here, so this here is our 55, 60, and this here gives us our contour for this section of the road, and this gives us our contour for this section of the road. And then what it is only a matter of finishing off this last section up here with 2 points on it, and do the same on this section, and then drawing in our tag poles. But this is how we deal with, we'll say, curved sections of road. Basically you're just going to do it the same, only you're swinging the arc around here. So you draw a height line from the center point here and mark off your heights on it and swing them around, and the same on the other side. The only thing to remember, these heights are going up the way because we're cutting away. In this question we're looking at 2009 ornery level question. So what we are given in this question is we're given 2 items to do. So the first item we have to do is we have to draw a profile from A to B. So what we're going to start off here is drawing all our height lines. So we've all our height lines, and what we're going to do is start off at a height of, using this line here, 20, and then work our way up. So basically what we're doing now is going to take heights from all of these positions here, bring them up and mark them off, and that's our profile drawn in this question. The next part of the question here, there's an observation tower from one of the points here. So from A it's brought up here, and what it is, you want to determine what's the height of the observation tower that can be seen from B. So similar to a question that we've looked at earlier in the lesson already. So from A, bring a vertical line up, and then from B draw a sight line touching off the side of the hill here, and this here shows the height of this observation tower, what height it has to be. Now the second part of this question is looking at the fill and cutting away here. Now what we'll notice here is the road here is 55 meters, and what we have to look at then is very carefully on the map here, is there any land at 55? So what we'll notice here is all the land here is lower than 55. So what we know in this question is all of this is going to be filled in. So in this one we're given a side slope ratio of 1:1. So this means that we're looking here at the intervals, the distance between the intervals is 5 meters, so that means our side slope, which is 1:1, 1 multiplied by 5 meters, so that means our height lines here are going to be measured out in 5 mil intervals. So from the edge of the road here we measure out 5 mils, that'll give us 3 points. Then next one here, 45, 40, 35, 30, and so on. So what we have in this question here is, and it's going all the way out to 10 here in this case here. Now this is one method of drawing all these height lines. Another method is where we bring out just one height line out from the side of the road here and mark off all these points on it and then bring lines across. So the 2 methods of drawing this. Then we draw in our profile, and then finally put in our tag poles swimming upstream. Now this is the 2011 ornery level question. So again, looking at this here, we have a profile section from A to B, and the second part of the question then is looking at, we'll say, a road here that's 25, and what you notice, all the land here is higher than 25, so it's going to be a section of cut that has to be done on the road here. So if we deal with the looking at the line from A to B, we set up our height. So again, look at the heights here. So the lowest point here on this height line here is 25, so we use this line here as 20 then, and then measure up 5mm intervals. Then what we're going to do is bring up all our points here. So all our points are brought up here, and that's our profile drawn in. Now in this question here is we have to locate the lowest point in the valley, and we'll say this here is the lowest point, so the lowest point is 24 meters, and then what you're told is that you have to draw 8 meters of water here to show how much of the section of the valley actually floods in winter time. So what it is up 8 meters here, so this here is the section of the valley that would flood in winter time. Now if we look at the next section here, so our ratio then for cut in this question is 1:1, and basically what we have to do is set up our height lines here. So looking at the interval height, they're 5 meter distances, so that's going to be 1 multiplied by 5, so all our height lines are going to be out in 5 meter intervals. Now so the road is 25, so our first line out is 30, because the road, all the land is getting higher than the road, so it has to be going up the way. So our first line is 30, that gives us 3 points, and then we move on 35, so on all the way out along, out as far as 60 in this question. So these are all our points marked off on our profile, and it's a matter of just joining up all these points again. So this here is what the cut looks like in this question, and finally we put in the tag pole symbols here to show that the land is sloping up the way. These are questions associated with roadworks, so these are ornery level questions. So what we have here is, the way these questions are shown is on one sheet we're given the actual question, and on a separate page on the end of the short questions you're given this. So this is the map that's given to you. So what we have here is, this is the map that's given to you, and what you have is, obviously looking at the map very quickly, A to B is going to be a profile, and then the other section then is we have to do a bit of cutting and filling on the road itself. So if we read the question, first of all, it's broken into a couple of parts. So part A, on the drawing supplied, draw a vertical section through the profile of AB. So that's straightforward. Next part here is, a vertical pylon is built at point A. On the profile, determine the minimum height of the profile if the top is to be visible from the ground at point B. So very similar to what we've done already. Now the next question here is, what we have in the question here is, the image on the right shows a section of new motorway linking Galway to Clare. Earthworks are necessary to accommodate the road as shown. So what we can see in the photograph here is, we can see what's happened at the side here. So what we have here is roadworks done at the side here, roadworks done at the side here. Now what we have here is, CD is a centre line on an altitude of 25 meters. So the road here is 25 meters. Now the side slope for cutting is 1 and 1, and the side slope for fill is 1 and 2. So there's both sections to be done here. Now complete the earthworks on the northern side. The southern side is already done for you. So what we have here is, we have cutting and filling to do. So looking at their 5 meter intervals. So what it is, we have what it is, 1 and 1 for cut, 1 and 2 for fill. So what we're going to be doing is measuring out 5mm intervals and 10mm intervals. So what we do here is, remembering the road is 25. So if we look here, this is a 25 point here. This here is 25 point. So this section is going to be filled, this section is going to be cut, and this section is going to be cut. So it's a fairly straightforward question. Next question here is similar question again. If we look here quickly at the drawing here, next question here is on the accompanying map on the back of section A, shows contours of 5 meter intervals. On the drawing, show a vertical profile through the line AB. Right, so we've a line AB in this question again. So if we look here, this is our line AB. So all we're asked for in this question is just draw the profile of it. And this time here then is the second part of it, is a line CD is the center line of a proposed level roadway, which is an altitude of 55 meters, using a side slope of 1 and 1 for both cut and embankments. Complete the necessary roadworks on the northern side. So quite a simple question here when we're given 1 and 1 for both of them. So what it is, it's 55 meters. So what we have here is, this here is 55 meters. So there's one point on the road that's 55 meters. So what we'll notice here is this section here is going to be cut and the rest of this section here is going to be filled. So we just set up our 2 height lines and mark off all our intervals along this.